Okay, this video is going to be really short. It's just a review of a couple things that you need to know before we go into writing equations of conic sections. So we need to remember how to find the distance between 2 points, how to find the midpoint, and how to write equations of lines. So really quickly, the distance formula and the midpoint formula are here. You will need to make sure that you know these for the next test. Okay, now to review how to write the equation of a line, we're going to write the equation of the perpendicular bisector. So let's make sure we remember what a perpendicular bisector is of the line segment joining the 2 points, -2, -5, and 10, 3. A perpendicular bisector is the line segment ray that is perpendicular and goes through the midpoint. So the first thing we need to do is plot and find the midpoint. Okay, that's as close as I can get, so now I need to find the midpoint. So I'm going to take the x, -2 plus 10 divided by 2. It's going to be 8 divided by 2. And -5 plus 3 divided by 2. That's going to give me -2 divided by 2. So my midpoint is 4, -1. To write the equation of a line, I need a slope, and I need a point. I know it has to go through the midpoint. The slope is going to be the opposite reciprocal of the red line. So the slope of the red, I'm just going to do rise over run. Rise 2, run 3, rise 2, run 3. So it looks like the slope of the red is 2/3. So the slope of the new line is going to have to be -3/2. And now I'm just going to put it into point slope. Y minus the y equals the slope. X minus the x. That's in point slope form. I'm going to solve for y. It's going to be y equals -3 over 2x plus 5. That's slope-intercept form. I'm now just going to remind you how to put it into standard form. So I'm going to add the 3 over 2 to this side. But remember, I can't have a 2 in the denominator, so I'm going to multiply everything by a 2. And standard form is going to be 3x plus 2y equals 10. And now I'm just going to plot it. Slope is -3 over 2. -3 over 2. -3 over 2. So that would be the perpendicular bisector. Now, what we're moving into, just to kind of give you a heads up, is we're moving into circles. And circles are a part of what are called conic sections, which you'll learn more about later. But I want to remind you that in a circle, a perpendicular bisector bisects this red chord in half. So this red chord, oh, I just lost this, here we go. So this red chord, the endpoints of the red chord are actually on the circle. This is the perpendicular bisector, so it bisects this chord in half.